Got it. Okay, guys, this is the Pythagorean Theorem, and we're going to develop acute, right, or obtuse triangles in here also. And don't forget our triangle inequality theorem. So everybody knows the right triangle. You got two legs, and you got this hypotenuse right here. And so you've probably seen the Pythagorean theorem before: a squared plus b squared equals c squared. All right, and so find the missing lengths, and so you just use the Pythagorean theorem. Okay, this one's the most common p triple. We'll talk about p triples in the next lesson, you guys. And so it's always x squared is always your hypotenuse squared. So I'm going to go 3 squared plus 4 squared equals x squared. All right, so there's that right there. And we've been doing these in our classroom quizzes. So 3 squared is 9, 4 squared is 16, and you add those together, you get 25. And so what number squared is 25? And that's 5. And it's called a 3, 4, 5 right triangle. 3, 4, and then this length is 5 right here. It's a 3, 4, 5 right triangle. Okay, so here's number 2. All right, and again, you got to watch out which one's the hypotenuse. There's the right angle. So the 15 is the hypotenuse. Okay, so that means this 12 squared plus this x squared will equal 15 squared. All right, so I wrote x squared plus 12 squared. Okay, so when I square those, and then I'm going to go ahead and subtract 144 from 225, and we get 81. And then what number squared is 81? Well, that's going to be 9. So x equals 9 on this one. Okay, easy, isn't it? All right, so in case you're wondering, I'm doing this in front of my class, my first period class, geometry class, and I'm going to go back and reteach it to them. All right, so this one's going to be 10 squared plus y squared equals 20 squared. All right, and then so 10 squared is 100, 20 squared is 400. So I'm going to subtract 100 from both sides, and I get 300, and then we're going to square root that. And remember, when you square root that, when you put it in simplified radical form, I teach my kids to get the prime factorization of 300. So remember factor trees, 300 is 30 times 10, which is 6 times 5 times 2 times 5, and break down that 6. Okay, so here's all the prime factors: 2 times 3 times 5 times 2 times 5. So I'm going to put them all in order inside the radical and pull 2 of a kind on the inside, brings 1 of them on the outside. So 2 2's will bring 1 2 on the outside. 2 5's will bring 1 5 on the outside, so you're going to be left with, there's my 2, there's my 5, and then I'm left with the 3 all by itself in there, so I get 10 root 3. Okay, and later on in this chapter, we're going to deal with 30, 60, 90 triangles. This is a 30, 60, 90 triangle, but that's later, you guys. Don't worry about that. Right now, we're just looking for x. Okay, here's the right angle, so that means this is the hypotenuse. So that means this side squared plus this side squared equals this quantity squared, x plus 1 quantity squared. Okay, got to FOIL that out, you guys. X plus 1 times x plus 1. And then let's clean it up. Looks like the x squareds, when I subtract out x squared from both sides, they cancel each other out. And there's it is right there. And then so now I got this simple algebra 1 problem. I'm going to subtract 1 from both sides and then divide by 2, and I get 24. X equals 24. Okay, so acute, right, or obtuse triangles. Okay, so if in a right triangle, or in any triangle, sorry, I don't know if it's right or not, but if the biggest side squared is greater than the sum of the squares of the other two sides, then it's an obtuse triangle. If the bigger side squared is less than the sum of the other sides squared, then it's an acute triangle. This is what the Scarecrow was trying to say in The Wizard of Oz, and he made an error on this, so he really didn't get a brain back then. So determine whether the lengths can be a triangle. If so, classify the triangle as acute, right, or obtuse. Okay, so here's number 1. All right, so can this be a triangle? Is 8 plus 11 greater than 13? Is 11 plus 13 greater than 8? And is 8 plus 13 greater than 11? And yes, yes, yes on all of those. So it is a triangle. So now I got to see, take the biggest side, square it, and see what relationship it has to this one squared plus this one squared. If it's bigger, it's obtuse, because that's what this says up here. If it's less than, it's acute. If it's equal, it's a right triangle because of the Pythagorean theorem. So we want to check out that relationship right there. How is 13 squared related to 8 squared plus 11 squared? All right, so you square those, and then you find out 64 plus 121 is 185, I believe. And since 169 is less than 185 over here, that would be, it falls into the acute category. Isn't that an acute little triangle? Slap your knee. Okay, how about this one? 5.8, 9.3, and 15.6. Okay, we got to check out. Okay, is 5.8 plus 9.3, is that greater than 15.6? No, so it's not even a triangle. So you're done with that one, you guys. You don't even need to go on any further because it's not a triangle. All right, so watch yourself when you're doing that on your homework on that. Okay, last part. Let's graph these points right here. And we're going to tell whether the triangle is acute, right, or obtuse. So we're going to use doing the squares. We're going to do distance formula and square it. And so let's go ahead and graph these points. There's my xy axes. Okay, and when we graph those points, there they are. And then I want to check out this length, distance formula, compared to this length, distance formula, and this length, distance formula. Okay, in case you guys forgot distance formula, there it is. That will be in the rest of your math life. So if you haven't memorized that yet, put that on your agenda to start memorizing, you guys. You'll see that over and over again. You'll see it in Algebra 2 and pre-calculus and calculus. So it'll just save yourself some time. All right. So I want to see what's the relationship with this side squared and this side squared. Okay. So I'm going to go ahead and do distance formula. So now when I square this radical, you guys, the radical disappears. So I just want to worry about the inside stuff. That'll give me AC squared. I don't want AC. I want to know what AC squared is. All right, so when I do all that work, I get 37. Hopefully I didn't make a mistake. My students will check on me in just a bit when we go through this. And then check out BC squared. Okay, so AC is 37 right here. So when I did all that, AC squared is 37. Now I'm doing BC squared, which is this length right here. BC squared, I get 20. And then I want to see the relationship right there. AB squared is 13. So 37, is that greater than, less than, or equal to 20 plus 13? So since 37 is greater than, it's an obtuse triangle. All right, if you are in my geometry class, looks like that'll be your homework tonight. Okay, take care.